Hello, welcome to EC222. Today I'm going to talk about how to understand our instruction reference documents. This is a request from students on Piazza. Sorry for the audio quality and some more issues. I'm not recording this in the best setting. So when you go and check for ARM, you will usually see that the documentation comes with writing like this. So you, for example, for the move instruction, we may have move, then we will have these curly brackets as conditional are the operand 2. And if you don't know what all these things mean, I understand it's quite confusing, because for many instructions you're going to have also this other format. So move, conditional are the immediate 16. So the first thing to notice is that the move itself, move, is what is usually known as the mnemonic. It's the mnemonic for the instruction, and it tells you what the instruction do. Sometimes this mnemonic don't tell you anything, so you have to go and surf through the whole documentation. Many times you're going to find some table somewhere that is going to tell you this is instructions names. My suggestion is just go print those tables. You need them next to you. Do not try to learn all the mnemonics. It's pointless. There are so many. Then, for example, for this instruction, we have this field here, this field in curly brackets. It's telling you that this is optional. So you may exclude or include the field depending on whether you put it or not. Something will happen to the instruction. The conditional is also optional. If you do not include this, the assembler will choose the default value and will use that one. And then we have the operands. So notice that all this is written as a word. For a real example, you may write something like move S, and then you put the conditional, let's say NE, and then you write the operands. So you can say I want move, sorry, R1 into R0 and update the flags and not equal. I'm not so sure if this in particular is valid, but that's exactly what that means. So you can include this or may not. So you can also say move R0, R1. And what's going to happen is that R1 is going to be written onto R0. No flags are going to be updated, and there is no condition to execute this. So it's going to be run every time. So that is what this part over here means. You have also this other format that does not update the flags, but does check the conditional. Interestingly, this is valid. This is not valid for the whole ARM instruction set. For example, in thumb 1, these conditionals are not, some of them are not valid. So you have to check specifically which subset you're using, because generally is for just ARM. Now, what does this mean, the immediate value? Well, immediate, let me write immediate. Where you see this immediate, and maybe you see a modifier like 16 or 8, or you even find a P in front, which is telling you this is positive, or you see an S. So if it is S is sign, if it is P is positive. What this means is that the value that you put in here is going to be codified within the instruction. So when the instruction is fetched from memory into the CPU, this number will come along with the instruction code. And that is very handy, because that means you can put constants or shifts or addresses, part of an address, within the instruction and save a lot of time and code it and run faster, because when you bring the instruction, everything is there. So the instruction does not require the CPU to go fetch data from memory to complete the execution, and that's very handy, but it comes with a drawback. For example, if the immediate we're talking about is an address, you cannot put a whole address, a 32 bits address, in a 16 bits immediate value. Therefore, you're limited to 2 to the power of 16 locations you can address. And the trick is that usually you will use some implicit value for branching and all that. Those instructions is going to be the program counter. So the jumps or branches are relative to the program counter. So immediates are just constants that are encoded within the instruction itself. So why do we have these two cases for the move format? Well, basically because there are two formats. There are two physical formats. I am using the thumb1 instruction set here because it's the simplest to use and has the less number of fields, and I'm just trying to convey what all these things represents and how they link to the physical binary encoding of an instruction. Once you know this, you just go read what is the instruction format, you put the numbers or the values or the fields, you fill them up, and then you assemble. If there is a problem, the assembler will give you errors, and then you just go and say, oh, I tried to use an immediate that is more than 16 bits and it's not allowed for this particular instruction. That's the important part. So then you can go figure out the details. Now if we look at this format here, so we have here is move for immediate. So this one correspond to this format here. And for the thumb one, so the immediate is not 16 bits, it's 8 bits. And you have to be aware of all these details sometimes, depending on what you're doing. For the microcontroller we're using in the course, it doesn't matter because it's thumb 2 and the immediates are 16 bits. But what you have here is exactly a one-to-one mostly correspondence to this thing here. So for example, here we have some fixed bits that are part of the instruction code. Then we have the opcode because there are different variants of move. If you see, there are 4 possible variants. It doesn't mean that they're all used. Then we have 3 bits. So this is 8, 9, 10. So we have 3 bits for RD. With 3 bits in thumb 1, we can only use R0 through R7. And that's a limitation of the thumb instruction set. In thumb 2, that's not a problem because there are 4 bits, so you can access the whole register set. And then you have an immediate that is 8 bits. And what's the reason for that? Well, because thumb 1 is a subset of the whole instruction set that codifies instructions in 16 bits. And that's very handy because you can have more compact code and use less memory to store that in a microcontroller, for example. So that's why what thumb1 was designed for machines with few resources. Now if we look at this one, clearly here we're using registers, and depending on the documentation you look at, they may join this H1 with op or may not. And what this means is, again, we have here an encoding that is fixed. Then we have the opcode for the different variants. And then we have a destination and source. So it's exactly what we have here. So operand 2 will be this one. It will be op2. And in this case, it's a 3 bits field that allows you to put in here the destination register. And RS is again a 3 bits code that allows you to choose the source destination registers. And the trick is that these two H1, H2 here allows you to choose whether this is going to be on the high part, so R7 to 15. There are limitations. You need to check the documentation for the most specific details. But that's exactly what these formats in binary look and how they correspond to the encodings that you're going to see. And this is basically all we can say about the syntax of assembly. Assembly does not have any specific syntax. You need to look to every instruction set architecture for the details. And basically what you do is you pick your mnemonic, you find out what operands you can put in there, and you use them. As simple as that. No if then else, no loops, no control structures of any sort. There are no declarations of variables or declarations of pointers. You have to make all those by yourself. If you want to make an if then else, you have to write it yourself. On future videos, I am going to teach you how to write if then else's and loops. Goodbye.